In working in section 9.3, we are going to find special products of polynomials. Two of the patterns that we are going to do, and there are three patterns altogether, the first two are called the square of the binomial pattern. These two patterns have a square of a binomial, a plus b quantity squared and a minus b quantity squared. And we can prove through foiling of these, showing that a plus b times a plus b is really equal to the a squared plus 2ab plus b squared. We can also show through foiling that a minus b times a minus b is really equal to the a squared minus 2ab plus b squared. These are two patterns that you're going to want to memorize so that when you see a quantity being squared, you can use the trinomial pattern in order to write the answer down without having to actually FOIL them out. This will help you later when we start actually factoring, going backwards with this. Let's show that the foiling works. We have a times a is a squared. We have the outside terms, a times b. And then we have the inside terms, which when you look at it can be thought of as b times a, but isn't that the same thing as a times b using the commutative property of multiplication? So I'm going to write a times b for that inside set of terms. The last terms then are b times b, or b squared. When you look at this, you can see that the a squared is the a squared in our pattern. The b squared is the b squared in our pattern. And when you look at these two terms in the middle, they are exactly alike. Well, when we have two things that are exactly alike, we can write that as 2 times that object. So 2 times a times b. Let's also look at the a minus b quantity squared and show that it is multiplied together in order to come up with this pattern. We have a times a, again, a squared. This time we have a positive a times a negative b. We know a positive times a negative is a negative, and we have a times b. Then on the inside, we have a negative b times a. It doesn't matter that, we have them in different order. It's still a negative times a positive. We're still going to have a negative ab. And the last terms are a negative b times a negative b. A negative times a negative we know to be a positive, and b times b is b squared. Again, as we look at this, we can see that the a squared goes to the a squared. The b squared is the same as the b squared. And this time I have two terms that are alike, but they're both negative. So therefore, we're going to have a negative 2 times a times b. Please notice that since we have a positive here in this problem, we are also going to have a positive in our first part of our trinomial. Here we have a negative. We are going to have a negative in our trinomial on the trinomial here that it is equal to. Let's apply this to a problem. We have 3x plus 5 quantity squared. You can start thinking of this as 3x, which this is your a plus b. So 3x is your a, so we're squaring our a. This is what we're thinking. And then we have to take the a times the b. So that means that we are going to take the 3x times the 5 times 2, because we're supposed to have a 2ab in the middle. And the last part is b squared. 5 is our b, so we're going to square the 5. Now when you're squaring that first term, that 3x, you have to square the constant and you have to square the variable. 3 squared becomes 9, x squared is x squared. With the 2 times 3x times 5, you can multiply those numbers in any order you want. If you want to multiply the a and the b together first so that you have 3x times 5 is 15x, and that times 2 gives you 30x, that would be awesome. Could I do it as 2 times 3 is 6, and then times 5 is 30 times the x? Absolutely. The last term up here is the 5 squared, which is 25. This gives us our trinomial, 9x squared plus 30x plus 25. You should, with the pattern, be able to go from the problem, 3x plus 5 quantity squared, directly to the 9x squared plus 30x plus 25 by squaring that a in your head. So you're squaring the a in your head so that you get your 9x squared, taking these two numbers times each other times 2 for your 30x, and then squaring that last term in your head to get the last term in your trinomial. Let's work on this with the negative, the 4x minus y, quantity squared. The same idea in terms of squaring, so we're looking at the 4x, that quantity squared. Then we're going to have minus 2 times the a times the b. The a is 4x and the b is y. Then we want to add the b squared, so we're going to have plus y squared. The 4x has to be squared, both the coefficient and the variable need to be squared, so that we have 16x squared. Then 2 times 4 is 8, and that will be a negative 8, times the x times the y. So we have a couple variables in that middle term. And then plus y squared. Again, I am hoping that you will be able to go from the 4x minus y quantity squared, square that first term so that you get 16x squared. Then take the a times the b, so you have a negative 4xy, times 2 gives you that negative 8xy. And finally, squaring the y, even if you think of that as a minus y, that's y is going to be positive when you square it, you will get a y squared in the end, positive. And this is our trinomial that we should have in the end. The third pattern is a sum difference pattern. If you notice, this is different than the other two. The other two were either both addition or both subtraction. That's why they were squared. This one has an addition sign in one and a subtraction sign in the other. Other than that, the a's and the b's are the same. And we say that this is equal to a squared minus b squared. Let's show through foiling how that middle term drops out, and you don't have a middle term. You just have the first and the last term. So we have a times a being a squared. The outside terms, a times the negative b is a negative ab. The inside terms is b times a, or as we've talked about before, a times b. And our last terms, a positive b times a negative b, positive times negative is a negative, b times b is b squared. You can see here that the a squared goes with the a, the minus b squared goes with the minus b squared that we can see, but notice what happens to the middle term. Those two are opposites of each other, and they cancel each other out. So negative AB and positive AB cancel. That becomes 0. We are left just with the a squared minus b squared. An example of r plus 3 times r minus 3. We want to work with that a squared minus b squared pattern. Recognize that your r is your A here, and your 3 is your B. So I have R as my A. That means I want to have R squared minus what my B is. My B is 3, and 3 squared. I have to simplify this, make it R squared minus 9. I hope that you are able to go right from the R plus 3, R minus 3, directly to the R squared minus 9. Think 3 squared, write the 9 down. One more example here, 4x plus y and 4x minus y. We are squaring the first term because this is an a plus b times a minus b pattern. That first term squared, that's that 4x squared minus the second term y squared. Well, in that first term we have to multiply everything in there, so that's going to be 16x squared minus the y squared. There is no middle term because if you are foiling this, these two terms, the inside and the outside, drop out. And all we're left with is our first terms being multiplied together and our last terms being multiplied together. Could you use FOIL to check these? Absolutely. But I highly encourage you to learn the patterns so that you're ready for when we start factoring trinomials along the way. Thank you.